Hello, everyone. My name is D'Angelo. First, I'd like to introduce myself. My name is, as I said, D'Angelo. I'm 26 years old. I'm international welding specialist, and in Bunorm, I had a similar way, similar path as Derek. I have been here for over 10 years, doing my job, and began as an apprentice. Was in the production line welding myself. Later, in 2020, I did my my school to the international welding specialist, and now I am in the role of the strategic welding solutions manager and head of non-destructive testing, head of welding robots, includes programming, and head of special project. As example, we have a certain project that is very new to us in the aviation. My qualifications, as I said before, it's the international welding specialist. I am certified visual tester level 2, certified penetration tester level 2, and have 10 years of programming experience on Yaskawa robots and over 10 years of welding experience. I will tell you a little bit about our company. Bunorm Maschinenbau AG was founded in 1965. We started out with simple welding constructions like rescue boards for firefighters and small parts like that. Later in 1984, we transitioned to machine engineering. That time, we bought our first CNC machine, which is a very early time, very early age of CNC machining. And just lately, 4 years ago, we joined the Swiss Factory Group. The Swiss Factory Group is a group of SME, small and medium-sized enterprises, all based in Switzerland, with the goal to use synergies and get stronger on the Swiss market. Some numbers. We have about 100 employees on 2 locations. We have about 10 apprentices on 4 different professions. And our biggest CNC machine can mill parts up to 3 by 3 to 18 meters of length. We are able to weld constructions up to 20 tons, and we are able to machine constructions up to 60 tons. We do have 2 welding robots of the brand Yaskawa. Both are programmed with the OLP from Visual Components. The first one you saw is has the operating length of 7 meters. And the second one is just stationary, about 2 meters of length and 1.5 meters of width. Then we have some other numbers. Certifications our company has. The first 3 ISO are pretty normal standards in the organization. You might know some environment and organization stuff going on here. Then the EN 3837 is, and the EN 1090 are like normal standards for steel construction and welding itself. And as you can read, EN 15085 is for railway production, and EN 9100 is for aviation, which we just recently got a new project. So what do we do? So our we do big constructions. We do all in one. So we can weld, we can machine, we do have painting, we can mount the pieces together. The goal is to give the customers one package deal. So you can order everything within one house. If you want just something welded, you can just order it, and then we will just weld it. But if you need like the full service with the mounting and the machining and everything, you can order that as well, and we can do everything together. That's our strongest thing we have about our company. Here you see, I will show you pictures about three big projects we have done lately. None of them are welded on the robot, just partially. I will get to that later. Here, this is a construct a small part from fiberglass production. It will get stacked up multiple parts of similar to these you can see on the screen until it gets, I think, 25 meters high. This one is a very big part, the biggest I personally have welded actually. It is for in the medical field, and the parts weight between 13 and 16 tons. The very latest project we had is this machine. This machine is for tunnel construction, not like for milling or something like that, but it will put up foil in the raw construction so that no water can get in after they finished the whole tunnel. Now to our welding robots. As I have mentioned, we have two robots. One is the newer one. We have got the Yaskawa YRC 1000. That's the controlling unit. We can weld up workpieces up to 7 meters length, 1.5 meter width, and up to 3.5 tons on it. And we can set it up in two configurations. One configuration is like this, where the rope, as you can see, the joint on the left, this piece, you can mount pieces on there, so you can tilt it also. You cannot just not only turn it, you can tilt it as well. The second robot is the Yaskawa DX200. We can weld workpieces up to 2.5 meter length and 1.5 meter width, up to 1 ton of weight. It's this one right here. Actually, on this robot, we just had the project. I want to show you how I programmed it, or just like as Derek showed you the seam, how that works. I will, in addition to that, show you how we work with measurements. Because as you can see, there are a lot of parts that are like, I don't know the exact term in English, but they're like burnt out of a plate, and they are very inaccurate sometimes. And we stick weld them by hand together, stitch weld them by hand together. Sorry, that was the wrong term. The little points, the dots you can see, those are like handmade from the worker, and then we load it on the robot and let it weld together. All right. So I'm just, because I had to restart my computer, I have to restart the Visual Components software, but that way you can also see how fast you are ready to work. Basically, what you need for programming is what I can tell you about. What you need for programming is like a CAD file that is very accurate to the workpiece you want to weld together. If you have no CAD weld, it's not possible to use OLP software. This is a very essential thing to have a exact CAD file of your workpiece. So this is the program. I have some trouble opening it. I think it's because my computer crashed. I will just open another file, one I didn't prepare. All right. As you can see, this is the workpiece, not exactly as I showed in the presentation, because I have like two operations of it. This is with the piece that gets on top with it here. Program that as well later. I do need here is this one out. term. So I'm gonna do it quickly as Derek did. I loaded the CAD file and I positioned it in a way I want to have it on the robot. And one thing I learned with OLP software is you have to think very good about your fixtures. How do you want to place the fixtures on the robot, because it might get in the way. As you can see, I kind of put these boxes here in the way, and they're very easy to put in. So when I weld here, I am able to see if it crashes into the fixture or not. All right, I have positioned my workpiece, and I will now change to the programming tab. Select my robot, and we're ready to go. What I do, as you have already seen, I will just click here on the weld button. It's like the same as Derek used this one here above. I will always use this one here down. And when I hover with my mouse here, you can see there's like a green one on the left, and on the right you can see a red torch. And if I want to go it the other way around, I just go here with my mouse, and the weld starts on the right side. So this is very very natural feeling of programming. Or if I want the torch to not look up, but to look down, I can change that as well. You can see it on the top right corner. Very easy to program with. Even if I mistakenly clicked here, start my weld, so now it's the wrong way, I just simply click on the path, hit on reverse, and now it's just the other way around. Now I mentioned the parts are sometimes not so accurate. So we use a lot of the wire measuring technique. To use that, we can simply press this button here, and then I can just select where I want to have my measuring points, 1, 2, and 3, and I have my measuring program here. Run that quickly through. You can see, okay, yeah, it's doing the movement I want. Sometimes I scroll a bit back, then you can see, I can see the arm fully, so it doesn't do any weird movements. But what I like to do with an easy weld like this is to just, I will delete this quickly. I just simply select this weld and press this button here. This button will just create the search movements as the program thinks it's the right way. Now I have these three points, these three movements, and I will just simply check them with the check path tool. And as you can see, I have some issues here. There is a green bar here below. I have a gray section here. That usually means that the robot is not able to reach that point. You can see it pretty far out. And I have a yellow section here. That means it collides with the workpiece somewhere. So what I do, I will first go to the weld. This is the collision here. And see what the problem is. I can enable detectors here, and they will see which parts are colliding. Sometimes the arm collides with a point of the positioner or something like that. So it's very easy to see what happens here, what's wrong. So I select this weld now and go to the point where we have some problems. I will just simply click the box so it's not so yellow and bright. And I see the problem is here at the end of the weld. Some of you might have already saw that from the beginning, that this will be an issue. It's very simple to have a solution to this problem. You just go to the Adjust tab here to the right. I usually have an offset of 3 millimeters at the end. I recheck, enable detectors. It's still a problem. And then we can just make a flare. I usually have like 25 millimeters here. So as you can see, it has created another step on my program. Then I will create a angle, flare angle. I usually take 25 degrees. And now let's check again if we still have a problem. Looks fine to me. Let's check again for the weld statement. So now, as you can see, it's all green, the bar, and we have no problem anymore. But we have still had some issues with this measurement statement. And we can just, to see where the problem is, we can scroll to that gray section and then double click here, and it will move right to the point where the problem starts. What I like to do, there's also various ways how to find a solution to this problem. I will go to the search tab now and try to tweak a little bit these configurations to see if we can handle this in a very easy way. So you see the arm is fully stretched here. I will now try to have the wire roll a little bit different. I just hover on with my mouse up here and scroll and see, oh, okay, the arm is now in a better position as before. I recheck, and bam, we have a solution to the whole thing. So let's check the whole program. Now the whole program is good to go. Derek already showed you the mirroring feature. I just can clone it to all these joints we have here. It's very easy. I'm not going to show it again to you. What I will show you is how I post-process it. So I will just simply click here on post-process on download, and we'll just export it in the folder I want. And now I have this untitled JBI file. I just left it as it is. And you can see with these 3 statements, I just created 41 lines of program. I would have written 41 lines of code on the controller itself. So that's my way of showing you how efficient this software is. With that, I have come to an end. So Ekaterina, you can take over with the questions. Please don't hold back. I'm happy to answer all of your questions.
Yes, thank you very much, D'Angelo. One question from Andre. D'Angelo, according to your presentation, it looks like your products are not mass production units. You produce a lot of unique assemblies. Is it profitable to write programs for each unique assembly rather than welded by hand? The question is not relevant to the program.
That's a very good question. The workpiece I showed you, this one, it had a, how do you say that in English? There was only 15 pieces the same. So it's not like mass production. It's still 15 same pieces, but without the OLP, we would not consider it to have we would not consider it to be efficient enough with the robot if we would program that by hand on the controlling. So I would say with online programming with the teach pendant, we would need at least 2 days of programming, and without, we took a half a day to program the whole thing.
Sounds great. Thank you, D'Angelo. Question from Julius. Can you easily program multi-layer welding seams as well?
Yes, in fact, I can just quickly show that to you. I have already done that. So what you do when you want to do multi-layer, you just click on that button here. First I have to choose the weld statement, then this button here, and this window will pop up. And here you can, I have preset here. You have to kind of find the settings for that and just take that preset, generate, and you're good to go. So it wasn't very obvious, but there are like 2 new lines here. And these are the multi-layer segments. Just easy as that.
Yeah. Thank you, D'Angelo. Okay, let's take one last question from Irene and then start wrapping up. So Irene is asking, what advice can you share with other manufacturing production managers who are considering adopting OLP software?
What I have to say about this question is I think you should test it if possible. I think you can easily get a demo license from Visual Components, get a instruction with Teams, and just test it out. I think you have seen a lot of things now from us, from me and Derek, how it works. Maybe I can share your experience. The experience I had when we decided to work with Visual Components. Vidisha, one from a worker from Finland, has flown to Switzerland. She measured the machine. She measured the whole jig from the robot and created the cell for me, and simultaneously teach me how to use it in those 3 days she were here. And these 3 days were enough for me to have a good enough foundation to work further and further and get my skills better and better. And if I had a question, I could always call Vidisha and send her an email, and she answered very, very quickly. So the support is really, really great with Visual Components.
Thank you. Great to hear. I'm getting more questions. I feel like some of them are even more towards us now. So, for example, asking, are there Comau robots in the library?
Oh, you have a huge library.
Yes,
Maybe I can open that up. This list you're seeing on my screen right now is just what you get for free. It's like, I think they have even more. Based from what I know, but I'm just a customer, I think Visual Components is like compatible with every robot brand.